So in this video, I'm going to show you how to do a variety of different basic statistical calculations using the TI. All right, so the first thing you're going to want to do is type your data into a list. Right? There's other ways to handle some of these computations, but if you want one-stop shopping, then this is the way to do it. So you go to Stat, Edit, and the first thing you'll notice when you go into My Stat Editor is you see a whole host of data points here, and so we want to get rid of that, or get rid of those. Right? So the first thing that I will do is go right up to the column heading and hit Clear, followed by Enter, and that'll wipe out the entire column, right, without taking away the column heading. So let's say I accidentally, on L2, accidentally hit delete. Like, oh no, there's my L2, or I'm sorry, L3, where's my L2? Well, it deleted the entire column, including the L2, from the list. And you can see here that I only have up to L6, so if I start deleting haphazardly, I'm going to lose column after column after column, and we're going to have a problem here. So again, it's clear and enter, or the down arrow will do the same thing. All right, but clear is the key. The key. All right, now if I want to bring back L2, what I would do, well, I hit delete to get rid of it, so let's do the opposite of delete, insert, to bring it back. So second, delete right on the L3. So right on the column you want to put it in front of, you hit second delete. It'll ask you for a name. It automatically puts the alpha lock on, but we don't really want that. That's if you wanted to create a unique name. We want to go back to the preloaded name, which is L2. So second 2 brings up the L2, hit enter, and it brings back not only the column itself, but all the information contained within the column. So I still have to clear and hit enter. All right. If you ever want to wipe out all the contents of the stat editor, you can go into the memory, second plus, and go to option 4, which is clear all lists. It'll say done. I can't really prove it to you because I already cleared out the information, but it will have cleared out every single column within the stat editor. All right, so what I'm going to do is I'm going to take this data set, the 0, another 0, the 0.5, the 1, and so on. I'm going to type that all into L1. Ideally correctly, so you always check your work. Oop, you see, almost did it myself. All right, so 21, 2.1, 2, 2, another 2. That's a little, probably too close to that 1.75, but we'll live with it. So I want to find the mean, the mode, and all that good stuff. So what I'm going to do is quit out of here. So second mode, I'm going to hit Stat, Calc, Option 1. Right, so we did Stat, Edit. And now we're doing Stat, Calc, Option 1. All right, one variable statistics. Hit enter. It asks you for the location of your list of data, L1. We didn't have a frequency list, so I'll leave that blank and go right to calculate. And it's going to give you a bunch of numbers. We got to parse through this. All right, you'll see an X bar that represents, in the one variable statistics, it represents the mean. Whether it's a sample or a population mean, it represents the mean. All right. So we'll round it to 3 significant digits, 3.0773. It will not give you the mode in this display, right? But if you hit the down arrow, it'll give you pretty much everything else that we want. All right, so the minimum, min x, 0. All right, so the mean, we use x bar. Lower quartile is represented on the calculator using a Q1. All right, and so that's 0.5. The median, 1.75. Yep, 1.75. The upper quartile, represented on the calculator with a Q3, is equal to 2. The maximum is 21. The range is the difference between the maximum and the minimum, which is 21 minus 0, so 21. The mid-range is the average of the maximum and the minimum. So 21 plus 0 over 2. So that's 10.5, 10.5. All right, it's not always half of the range. It just works out in this case that it's half the range because the minimum value is equal to 0. All right, the interquartile range is the difference between Q3 and Q1. So 2 minus 1/2. So 1.5. All right, we'll need to construct a box plot. We'll need to determine if there's any outliers. All right. Now, the box plot function on the calculator is pretty convenient. All right, and so is computation of outliers. All right, there's formulas and processes for doing both on paper, but I want to show you the calculator approach. That's the whole point behind all this stuff. All right, so we'll come back to the mode. We'll actually do the mode last, but let's go to the second y equals menu, which is our stat plot menu. And you see I have some other functions that are set up here. All right, so the first thing you'll notice is that regardless of what the settings are initially, they should all be set to off. You know, whether it's a scatter plot or a box plot that I have down here, it should be plot 1 off, plot 2, and plot 3 off. All right, if you go into y equals, you see across the top row, plot 1, 2, and 3 should all be unhighlighted. If they were highlighted, it would look something like this. That would mean that the plot is actually on. And that could interfere with any function graph that you're trying to make. All right. So second y equals, I go into one plot at a time. I'm going to go into plot 1, hit enter to turn it on. Now I want a box plot. So I hit the right arrow until I come up, or I come to the graph that looks like a box plot. There's two types of box plots. One is what we call a modified box plot. Those little 2 dots off on the side, those little 2 dots are outliers. If there are any outliers, it'll come out in the box in the modified box plot. But for now, it just said construct a box plot, not a modified box plot. So I'm going to hit enter on that. XList, L1, that's a true statement. Frequency list, now this part is a little annoying because when you go through the stat calc 1 to come up with your summary statistics like we did, we got the lower quartile, the median, upper quartile, and all that stuff. We left frequency blank there. Here you want to leave frequency at 1. And I think it's a flaw with the programming, but it is what it is. All right, what this means is that every element in list 1 only occurs once. Right? You're not saying that they occur, 5 times each. All right. So once you do that, what I like to do, because I want the calculator to do as much of the heavy lifting as possible, I hit zoom and then option 9. That's the one that says zoom stat. Makes sense because you want a zoom based off of the statistics that you entered into the stat editor. All right. Now you see here, I get a nice looking, almost nice looking box plot. And I also have a nice looking sine wave and a little extra bit of smidge there. That's because you might have remembered this when I hit y equals, I had 2 other functions in here. Now you can see plot 1 is on, but I don't want to see these other functions. I could turn them off, but I don't really need them, so I'm just going to delete them. All right. So that's what my box plot looks like. So then the only thing you'd have to do is, using an appropriate scale, get that down on paper. All right. So assuming that I didn't do the one variable stats, stat calc 1, I could just hit trace and hit the left and right arrows, and it would tell me what values I would need to have plotted on paper in order to construct this box plot. All right. So for the most part, we're just going to need a rough sketch. So all you would need to do, you know, you have a 0 here, let's say a 25 here. You would need to have a lower and upper bound on a number line that are below and above your minimum and maximum values, or at least equal to or below or above. All right. If it's something like 0 as a minimum, you don't need to get into the negatives. Just you want to make sure that you capture the entire graph. Most of the time, you just kind of you can't expect clean numbers, is what I'm getting at. So if you end up with clean numbers, that's wonderful. But generally, what we do is we pick a nice interval of values that surround the minimum and maximum. All right, and then increment your graph to account for all the values that exist in between. Right. So I'll go by 5s here. And because I have digital inking capabilities here, I can just kind of tweak it so that the spacing is somewhat reasonable. All right. So then I would plot a point for the minimum. The lower quartile is very, very close to the minimum. So is the median, so is the upper quartile. The maximum's up here at like 21, so way up there. But the other 3 values, so if we break up this interval here into subintervals, we'd be looking at a point here, a point here, and then a point here. All right, so we would create a box around the middle 3 points and extend outward to the extremes. And that, again, is only assuming that you need to actually put a graph on paper. All right, but that's what your box plot would look like. All right, a requirement I have for my students is when you have to do it on paper, that you also label, whether it's on the scale or on the graph itself, the numerical values. All right, just so I know what you're trying to go for. So if it's a little off, at least I know what you're aiming for. All right, so that's what your box plot ought to look like, something like that. All right. Now for outliers, this is the really cool twist on this. You don't need to do any computation by hand. All you have to do is graph a modified box plot. So the one with the little dots. Same scale, so you just hit graph. You don't have to hit zoom anymore. Now you see that you have a separated point. So hit trace, count off 5 points. Minimum, Q1, median, Q3. You got another point that they call X. That's the maximum value if you remove any outliers. You should have 5 values to make up your box plot. Anything beyond that 5th value from the minimum on, anything beyond that 5th value is an outlier. So hit the right arrow one more time, it brings you to that maximum point. Calculator doesn't know any other way to label it. We have an outlier of 21. Now, based on the definition of an outlier, that should actually make a whole lot of sense. All right. Now, in terms of the mode, this is kind of a weird thing because you look at the mode and say, well, I don't need technology to do that. Well, yeah, I agree. You probably don't need technology to do that if you only have 10, 12, 20, 30, 40 values. But if you have 5,000 values, yeah, you definitely need technology to do that. And if the numbers are disgusting, you absolutely need technology to do that. So let me just show you a very quick way of doing it, and it involves a histogram. So what you do is you go back into the stat plot and select the histogram option. Same settings as the box plot. All right. You could do a zoom 9, but then the calculator decides what the width of each interval is going to be. We don't necessarily want that. What we do is we go into the window and we put the minimum value. We put the minimum value as whatever the minimum was for the box plot. The x min is whatever the minimum is. The x max is whatever the maximum is for the box plot. The x scale is equal to 1. Then hit graph. All right. You see here we have a piece of a bar. We don't have an entire bar, so let's expand our window to go a little bit further. Make that maybe 22. You could even go 25, like we did for the box plot. Then hit trace, and it'll give you the heights of the bars. But these bars have 1 unit in terms of width. All right, so that it's basically overgrouping the values. All right, so if I hit trace, like I said, we have 3 values between 0 and 1, and 0 and less than 1. All right, 0, 0, and 0.5. 3 values between 1 and less than 2. So 1, 1.5, 1.75. So what this serves to do is give us a way of narrowing down the field. You know, where are most of the values? It looks like most of the values are between 2 and less than 3. All right, but if I want to be able to identify the most of a unique value, or the most times a unique value occurs, I would want to restrict the length of my interval. Right, so the way I would do that is look for the smallest decimal increment. All right, so I got 0.5, 0.75, and 0.1. All right, so that's telling me I really should be, instead of going by the x scale of 1, I really should be going by 0.1. Right, the problem is the calculator is not going to be able to graph histograms with this domain going from 0 to 25 with widths of 0.1. All right, so that's saying, you know, 10 little bars in between each integer value. All right, so it's going to have to create a histogram with at most 250 bars. That's not going to fly. So you hit graph, it says error stat, which kind of makes sense. But that being said, we kind of know where to look. I mean, we never thought that 21 was the mode. All right, so we can kind of restrict our way down to a more reasonable domain. Like, for example, if I were to go from 0 to 2.1 rather than 0 to 21 or 25 as I had it initially, with increments of 0.1, maybe that'll do the trick. All right, so now what I'm looking at is a graph where the bars are a little bit more obvious, all right, or obviously tied to the numerical value. So I hit trace, values between 0 and less than 0.1. There's 2 of them. That would be the 2 zeros. Values between 0.5 and less than 0.6. That would be the 0.5 because there's only one of those. Values between 1 and 1.1 and less than 1.1 would be the 1. We have the 1.5. We have the 1.7. But then you see that we have 3 values between 2 and less than 2.1. All right, that would be our mode because that number must be the 2, and that one occurs more frequently than everything else. All right, so that's what I would conclude. My mode is equal to 2. Now, obviously, I took us down a rabbit hole here, making this seemingly way more complicated than it needed to be. However, we learn from small data sets so that we can project onto larger data sets. So when you have something that's a lot more complicated, you can use a technique like this. All right. So what I mean by complicated is a much lengthier data set.